Hi everyone, today we're going to interpret distributions using histograms. We're also going to find the measures of center and spread and then use SOCS to describe that distribution. Get ready to unlock the power of math together. Let's dive right in. In this histogram, we are shown the annual amount of rainfall for various cities. We're going to use this histogram in order to answer the questions. So we want to find out how many cities were included in this study, which means we have to look at the number of cities in every bin or every bar or interval. So we have 3, we have 2, 4, 6, 8, and 3. So when we're looking at how many, we're going to total up the cities that we have, and that would get me 25 cities. Now, which bin would have the data value of 34? So the 34 would be in this bin right here, which is bin number 1, 2, 3, 4, 5. So in bin 5 would be the data value of 34 inches. What percent of cities have less than 32 inches? So here is 32. So now we're looking at these bars right here. So that's going to be the 3, the 2, and the 4 out of a total of 25 that we found earlier. So that is 9 out of 25, which is 0.36, which is 36%. And then what percent of cities have at least 36? So that's 36 and above. So that's going to be 3 out of 25, which is 0.12, which percent is 12%. So now we're going to find the measures of center and spread. So you can think about the center being, right, your central or sort of that typical value. And then the measures of a spread, we're kind of thinking about how spread out the data is. So here you've got 20 golf members on a team, then they each hit a golf ball. And in this table, you have the distance that is traveled, and that's in yards. So when you are doing this, you could actually use your calculator to figure this out. And we'll go ahead and do these sort of steps together. Okay, so to find the measures of center and spread using the calculator, we're going to go to Stat and option number 1 in the Edit menu. And in L1, we're going to enter all the data, sort of putting one number in each row and then pressing Enter every single time. All right, so once you have all your numbers in L1, you are going to press Stat again, and you're going to arrow right to the Calculate. And option number 1 says 1 var stat, and then you're going to press Enter. So if your list is in L1, you're going to have L1 listed right here, and then you're going to enter until you hit Calculate, and you're going to get all the data here that we are looking for. And then you also remember to scroll down and you get the 5-number summary. So here we have our information. Now what we're going to do is we're going to use this information and we're going to find the measures of center and of spread. So when we are trying to find the mean or the average, we are going to look at X bar. So X bar is this number right here. So that is represented by 209.3. Our median, which is here, that was 205. When we're looking at spread, we are looking at standard deviation. So we're looking at SX or S of X, and that is right here. That is 24.6. When we look at range, we are taking the maximum and subtracting the minimum. So we're taking 280 minus 185, which is 95. When we are doing the IQR, what we are doing is we're looking at sort of how spread out the middle 50% of that data is. So what we're doing is we're taking the Q3 value and subtracting the Q1 value. So that's 212.5 minus 195, which gets you 17.5. Now we're going to use the information that we have from the histogram that we made from the data, and then we have the data table right here again, and we're going to describe the distribution using SOCS. So it's SOCS. So the first S stands for shape. Okay, we want to talk about what is going on with the distribution. Now you're going to see majority of your data is to the left, but we do have a little bit on the right. So what happens is that we notice the distribution of golf distances, so to say, is right skewed. So it's skewed to the right, or you could say positively skewed. When we look at O, we are talking about the outliers. So we're going to talk about the fact that we had in our table, we had these values of 270 and 280. So there appear to be outliers at 270 and 280 yards. When we look at the C, we are looking at the center. So when our data is symmetric, we're going to talk about the mean. So when our data is skewed, which is in this sort of distribution that we see, we're going to use the median. So we're going to talk about the median distance. So the median distance we found from our 5-number summary that was from our calculator, and that median distance is 205 yards. So the last S that we're talking about is the spread. So when we're looking at the spread, we're either going to be talking about the IQR. In this example, because it is skewed, we'll talk about the IQR. When it is not skewed or when it's symmetric, we're going to talk about the standard deviation. So here, because this is skewed, we're going to talk about the middle 50% of distances. And when we use the IQR, we're looking at Q3 minus Q1. So you can say that the distances are between whatever those values are, Q1 and Q3, which was 195 and 212.5 yards. Or you can say the IQR is, and then the IQR value that we found was 17.5 yards. Now, the reason why we talk about using the median when the distribution is skewed is that because you sort of have this little tail on the right, that mean is sort of misleading for you to use because it's pulled to that tail. So that's why we use the median, because the median sort of gives us a better typical value. So that's why we use that for the measures of center. Now in this histogram, we're looking at the number of hours spent playing video games, and we want to know what's greater, the mean or the median. So what you want to think about is how is the distribution? Is it symmetric or is it skewed? In this case, since the distribution is left skewed or negatively skewed, what happens is that the mean is pulled in that direction. Okay. Now, what that means is that then the median, we know, is greater than the mean or the average. Right? So if the middle value of our data is, let's say, somewhere over here, the fact that you had a couple of these lower values that pull that average to be lower, the median would be greater than the average. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for future notifications on other pre-calc videos. See you in the next lesson.